Welcome to this lecture on polymorphism. Imagine a person is talking to his father and a person is talking to his son. The way the person talks to both of them are different because the person who is talking is either a father or a son. Now, polymorphism means more than one forms. It provides a single interface to different types of entities. In this video, we're going to learn how to define polymorphism, identify polymorphism in real life, list 3 different types of polymorphism that exist, explain function and operator overloading, describe parametric polymorphism and subtyping polymorphism. It's a Greek term called polymorph. Poly is many, morph means form. An object can exist in different forms. It's the same object, but it can behave differently at different circumstances. It provides a single interface to entities of different types. I can realize an interface using different types of objects. As an example, look at a camera. When you think of a camera to take a picture or to turn on or turn off the flash, and that's what is an interface. But how do I realize that? So I can realize a camera using a smartphone or an SLR camera or a Polaroid, analog, or even for that matter a webcam. All of them have these features. So a mobile phone cannot be compared with a camera, but mobile phone has that feature. So we can realize a camera using a mobile phone. So the relationship here that is achieved is a realization relationship. So there are 3 types of polymorphisms: ad hoc, parametric and subtyping. Let's look at each one of them in detail. Let's begin with ad hoc. Ad hoc is about function or operator overloading. Now what is function overloading? Look at a function called add. In this example, there are 2 numbers being supplied to the add, and you may very well expect that the number gets added and then a return value will be received. Here is another add, but this time I am supplying a first name and a last name. And when I supply this first name and last name to this function, it's just supposed to concatenate and return that. What about a function to supply a date and number of days? Now this is expected to return a future date from the source date. Now each one of them have the same name, add, but their parameters are different. Now this makes it different when you call it. So if I supply 2 numbers and call the add function, the very first one is called. If I supply a date and a number, then the third one is called. So usually the programming language compilers are smart enough to figure out that you supplied numbers, I will call the numbered functions. And this is how the function overloading works. Now some languages allow you to redefine the behavior of an operator, and then it's called as an operator overloading. Now think of 2 employees, Scott and Miller, and I'm going to add Ross to Scott. Now this time it's not a number, so I can't really add. So I can define the meaning for plus equals to as to add Ross to the name of the person called Scott. So which means now eventually Scott's name will be Ross Scott. Now I might even add 500 here. For example, this time his name wouldn't become 500 Scott, but I might expect his salary to be hiked by $500. Now here we are comparing Scott with Miller, and I'm comparing Scott with 6,500. What are we doing here? Now in the first scenario of comparison, Scott is being compared with Miller, but you need to define what is that comparison. Maybe it is his salary, so Scott's salary with Miller's salary, Scott's height with Miller's height, Scott's lengthy name we compared with a Miller's short name or something like that. Now you need to define that. In the last one it was easy because you're comparing a number, so it's quite obvious that you're comparing is Scott earning more than $6,500. Now that's how you define this particular overloading. Let's move on to the parametric polymorphism. Now parametric polymorphism allows a function or data type to be written generically. What do you mean by that? Now here a function can handle different types of data. The actual activities involved in the function remains the same, but they work on different data types. In certain languages like Java and C#, it's called as generics, and in C++, it's called as templates. Here is an example. We have a data structure class called list. By the name of it, you can think that it represents a list of items. But what kind of items? Did we mention that? We have not mentioned anything like it is a list of integers, list of strings, list of employees, and so on. But we just mentioned that there is a function to add an item, remove an item, or find out what is the size of the item. Now here is the way you say that I want to work with a list of strings. So we define a names as a list of strings. Now you can only add strings to this. The add function, the remove function, the size function, all of them are working with the strings. On contrary to that, we have here a usage of the same class, same definition, same functions, but they work this time with integers. Now, when I say add 123, add 223, the list grows, but if I type add Vinod, that's going to be an error because string is not allowed in this scenario because we said that the list has to be used with integer. Now, this is parametric polymorphism. The third type is subtyping. Here, it's also known as inclusion polymorphism. Involves supertype-subtype relationship. Without this, this is not going to work. Now, as an example, we have shape. Now, shape, if I ask you to picturize a shape, I don't know what you're picturizing, but I'm sure a shape can be realized by using a square or a triangle or a circle. Now imagine I would now want to find out what is the area of the circle or area of a rectangle or area of a triangle. Now this is where the function area or calculate area varies from shape to shape. Now for each one of them there is a different formula. So when I say shape S1, it's very generic. We say, hey, what's the area? We don't know because there's no formula for calculating the area of a shape unless you tell what kind of a shape is that. So if you say, what is it? We don't know. But on the other hand, if I say S1 is a circle now, and I say, what's the area of the circle? And I said that the radius probably is 12 units. Now, based on this, applying the formula, the calculated area would be something like this. Now, on the other hand, S1 is now referencing to a triangle, and now I say, what's the area? Obviously, this time it's supposed to use a different formula. Now, the formula would eventually multiply the two numbers and divide it by half. We get something like 100. What about a rectangle? It's a different result too. Now, what is supposed to be assumed or understood here is that these three functions are exactly identical for the compiler. S1.calculate area, S1.calculate area, S1.calculate area. There's no difference. But you saw that the output of this varies. So it is the same behavior called, but the way it behaved was different. Now remember the talk function by a person. When a person is a father, he is talking a different way. When he is a son, he is talking a different way. That's exactly what is this. Now S1 is the same object, but it's behaving differently based on is it a circle object, triangle or rectangle object. Now subtyping always overrides a method from the supertype when you're talking about this kind of polymorphism. Now, also known as polymorphic method. In the example that we took, calculate area is a polymorphic method because when you call it, its behavior changes. Now, let's summarize what we learned so far. Now, polymorphism is to have an object in different forms and it provides a single interface to different objects. And there are three types: ad hoc, parametric and subtyping. Now parametric polymorphism allows a function or data type to be written generically, and in subtyping, subtype always overrides a method from the supertype.